Let's continue with the solution to these AP Physics problems. Now, we are on question number 4. It says a ball is thrown with a velocity of 20 meters per second at an angle of 30 degrees above the horizon, that is above the horizontal. When the ball reaches its highest point, which of the following is true? Let's sketch a path of the ball. So let's say the ball was here initially and it was thrown. So it's going to take this path, this parabolic path, and then it was thrown with an initial velocity of 20 meters per second. From what we know, since this thing was thrown at an angle of 30 degrees above the horizontal, at an angle of 30 degrees above the horizontal, it implies that this body will have both vertical component of velocity and horizontal component of velocity. And from what we know, as this body is going up, as it's going up, it will be changing its vertical component of velocity. And in what way? It's decreasing. So the vertical component of the velocity is increasing, but the horizontal component of the velocity is never changing. The horizontal component is never changing. So it continues like this. It still has the horizontal component of the velocity, which will not change. But here's what happened: as the vertical component is going up, it is actually decreasing. Then when you reach maximum height, the maximum height reached before the body begins to fall down again, the horizontal component still remains the same, that is Vx. But at this point, there is a kind of momentary stop in the vertical direction. So the speed in the vertical direction, sorry, the velocity in the vertical direction will be equal to 0. However, the horizontal component still remains the same. There is still a horizontal component. So, and the velocity of this body, the velocity of the body is given as Vxi plus Vyj. So the only thing that is going to be 0 here is the Vy part, but Vx is still going to be a non-zero value. And because of that, this body still has velocity. Hence, you cannot say that it has 0 velocity. So option A will not be correct. It says it has 0 acceleration. This is also not true as well. It has only vertical acceleration, which is acceleration due to gravity in this case. Of course, since Vx is constant, there will be no acceleration in the horizontal direction, because if velocity is constant in the horizontal direction, there will be no change in velocity, and hence there will be no acceleration in the horizontal direction. But because the velocity is still changing vertically, so it's changing, it's decreasing as it's going up, then it's increasing as it's coming down, so it's still going to have acceleration. So 0 acceleration is also not going to be correct. It says it has minimum potential energy. This is not going to be true. At this point, it has reached its maximum height. It has reached its maximum height. And when you have reached your maximum height, you cannot have minimum potential energy. At that point, you have maximum potential energy. So this says it has minimum kinetic energy. Minimum kinetic energy. Of course, this is going to be true because at that point, the speed is going to be the minimum. And so, because of that, this is the correct answer to that question. Yeah, let's move on to the next one. So the next question says that if 0.5 kg mass hangs from a spring scale, it is placed in a container whose water level is initially at 1000 milliliters. The water level rises to 1200 milliliters when the mass is placed in the container as shown. What is the reading on the spring scale when the object is in water? So this is a question on the force of buoyancy. And the first thing we need to note there is that we need to find the actual weight of the object, the weight in air. So let's find the weight in air. That is just 0.5 kilogram multiplied by acceleration due to gravity, which is 10. And this will be 5 newtons. So the object itself, this object, weighs 5 newtons in air. Now, let's now see what happens to it in water. In water, the total weight in air is actually the sum of the force of buoyancy and the weight in air, the weight in water, and the weight in water. So what we need to get is the weight in water actually. We have the weight in air already. We can also solve for the force of buoyancy. To solve for the force of buoyancy is simply rho Vg, where rho is density of water, V is the volume displaced, and G is acceleration due to gravity. And when you look at this object, it was totally immersed in the fluid. It was totally immersed in the fluid. Since it was totally immersed in the fluid, then we know that the volume displaced is going to be the actual volume of the body itself. So here, initially the water level was 1000 milliliters. Now it has risen to 1200 milliliters. So that implies that the volume displaced is going to be 1200 minus 1000, which is 200 milliliters. And if you convert this into meter cube, just multiply by 10 raised to power negative 6, and that'll be 2 times 10 raised to power negative 4. 2 times 10 raised to power negative 4 meters cube. So that's the volume displaced. Then the density of water is 1000 kilogram per meter cube. And then we know that G, we're going to be using 10 meters per second squared here. So if you multiply everything here, so you have 2 multiplied by 1000, 2 times 10 raised to power negative 4 multiplied by 1000 multiplied by 10, that will be, so this is 1000, this is 10, so that will get rid of that. So everything here is going to be 2 newtons. So with that, we know that the weight in air, which is 5, is going to be equal to force of buoyancy we just got here is 2 newtons plus weight in water. So weight in water is then going to be 3 newtons. So weight in water is going to be 3 newtons. So the question says, what will be the reading on the spring scale when the object is in water? The spring scale is necessarily what is measuring is the weight of this object. But because there is an apparent loss in weight of this object, it's not going to be reading 5 newtons anymore. It's going to be reading 3 newtons at this point because of the apparent loss in weight that the object is feeling. So the correct answer is 3 newtons. I'll continue in the next video.